In this video, I'm going to describe the key features of the Chemistry Department's provision for the AQA A-Level and the IB Diploma. This year, Rugby School students will be given the choice between the two specifications. Although we shouldn't make any direct comparisons, there are some general comparisons that I will make at the end of this video. In front of you is the department's own scheme of work for the AQA A-Level. It's very similar to the scheme of work you were given at IGCSE. So you can see this one is for the lower sixth. There's an equivalent booklet of about the same size with the upper sixth material. And you can see the date 2020 to 2021. The specification is changed slightly year to year, and we do update this booklet to reflect that. For both the AQA A-Level and the IB Diploma, there will be two chemistry teachers. So each chemistry class will have two chemistry teachers. Half of the lessons will be with one teacher, half will be with the other. The material taught by one of the teachers is shown in highlighted and bold text, and the topics taught by the other teacher are shown in normal font without highlighting. Very broadly, one teacher will teach the more mathematical sides of the course. The other teacher will teach more sort of the chemistry of carbon and its molecules, what I would call organic chemistry. Looking inside, the final exam for the AQA A-Level is composed of 3 papers. Paper 1 covers the broadly mathematical side of the course, and this is 2 hours long. Paper 2 covers both mathematical and parts pertaining to molecules of carbon, which, as I say, is called organic chemistry, and again that is 2 hours long. Finally, paper 3 is a synoptic paper that covers all parts of the course, including practical skills. So throughout the course, you will be doing experiments, and this is required by the exam board, but it's assessed on a pass-fail basis by your teacher, and periodically the school gets moderated to make sure that we're doing the practical work properly. It's worth noting that in paper 3, around half the questions will be multiple choice. In papers 1 and 2, the questions are either calculation based or require some sort of answer given as a sentence. In all papers, you will be given a data booklet. So this is just a booklet of chemical data that you don't need to memorize, because it will be given to you in the exam. This will include the periodic table. Okay, and just as an example of this, we have the data book here at the end of the scheme of work. Okay, so this booklet that I'm going through, you'll be given on the first day of the AQA A-Level course. Okay, so the data booklet I have here, there's the periodic table, very, very similar to what you're used to at GCSE. This island at the bottom, okay, is omitted from the simplified GCSE version that you have. We call them the lanthanides and actinides. Also, the level of accuracy of the relative atomic masses is now 1 decimal place, whereas at IGCSE they were rounded to the nearest whole number, with the exception of chlorine. And there's other data here as well, okay, that will make more sense to you as you progress with the course. In all papers, you will be allowed the use of a scientific calculator. As I mentioned previously, practical skills will be assessed internally on a pass-fail basis, and the school periodically gets moderated to check that we're doing that properly. The most recent moderation was in 2019. And at the end of the course, you will be given a grade between A star and E, and obviously A star is the highest grade achievable. There are several AQA A-level textbooks. This is the one that we recommend, and I have a copy of that textbook here. So just quickly looking inside, so you can see, first of all, it's a fairly thick book. I don't know if that's clear from the video, but looking inside, it's very, very detailed. So it goes through absolutely everything that you need and a little bit more. Your chemistry teachers will obviously be very selective in teaching you exactly what's required for the exam, but it is sometimes good just to have a textbook that goes a little bit further and maybe provides a little bit of detail in an area that you wanted to look at further. You can see that there are various questions throughout the textbook, and at the end of the textbook there are the corresponding answers, so there's certainly no shortage of practice if you wanted it. We also recommend a revision guide. You'll see from the cover that it's very similar to the revision guide that we recommend at IGCSE, and inside the layout is very similar. Okay, so unlike the textbook, this is the bare facts. Very, very useful for revision. But it's obviously useful to have the revision guide with the bare basics required for the exam, coupled with the textbook, which contains everything in a little bit more detail. We've found that that combination works really well. In addition to these, of course, you will have your class notes. There's also a website that you may want to have a look at. It's called Chem Guide. It's not specifically for the AQA A-level, but it is certainly recommended, and it does contain lots of useful information. It's written in general for the English A-level, okay, but not necessarily for the AQA specification. So just looking inside the specification, we've laid this out in a very similar way to the way that we laid out for you at IGCSE. So each of the points has been cut and pasted directly from the specification. It's been rewritten in a way that's less technical and more easy for students rather than teachers to understand. And next to each statement is the corresponding page number from the big textbook that I showed you. And so the idea is that as you go through the course, and the teachers should go through these points in chronological order, as you go through the course, you can tick off each point as you go through it. If you're not happy, you can have a look at the textbook page number, and as ever, you can follow up with your teacher and they will see you one-to-one if needed. In terms of the A-level exam paper, I've got an example here. So there are three broad observations I would make about the AQA A-level. The first one is that you need to be quite good at problem solving. You need to be quite good at being able to deal with unfamiliar and new situations and being able to manipulate the data if given. So for example, this question here is on a topic called electropotentials. So it's to do with batteries, or as we call them, cells. And although the students had come across the chemistry behind this question, it had never been presented to them in this way. Okay, and in particular, we've got a natural log here that the students wouldn't have come across in this context. Okay, so students would have come across natural logarithms in chemistry, but not in this particular context. So just in the exam, they had to deal with that data and they had to use it to plot a graph, okay, again, under the conditions of the exam. So it's just a case of holding your nerve, knowing what you've been taught in class and being able to apply it in unfamiliar situations. And over the page, the question continues. Okay, and again, this is an unfamiliar equation. Okay, so it's not on the specification, but it's presented here in this paper in a problem-solving context. Okay, and you can see y is equal to mx plus c. Students expected to have a reasonably good grasp of maths to be able to answer the questions in chemistry. So just comparing this with GCSE, at GCSE the questions are sometimes quite predictable. They're often quite repetitive, and calculation questions tend to be broken down into individual parts, and it would be very unlikely that you would be asked to manipulate data in an unfamiliar way. Okay, at A level, all of those things are now expected. Okay, maths is much more important. Okay, it is certainly a big benefit to be doing A-level maths at the same time as A-level chemistry. It's not essential, we don't ask for it, but it is certainly a benefit. Looking at another A-level question. So here, again, just to emphasise, so we have a question here that is part of the syllabus and will have been specifically practised by the students, but you can see it's worth 6 marks. So as I say, at A level, you can't necessarily depend on these big calculations being broken down into bite-sized chunks. Okay, it's quite possible that you'll be given a fairly big mathematical question and expected to work out all 6 marks from there. Finally, this is another A-level question. So this relates to an experiment that's similar to one that would have been done in class. You can see that it's a fairly big question, 6 marks long, and the students have been given all of that page and all of the following page to write an answer. So again, that's quite a contrast to IGCSE. Okay, at IGCSE, we would be used to 1 mark, 2 mark, maybe 3 marks. Okay, and anything more than that would tend to be something that we'd practiced specifically in class. So I'm thinking in particular making salts at GCSE. At A level, it's much more common to be given a more general type question and expect you to come up with 6 marks and potentially to write 2 pages on it. Turning now to the IB Diploma. This is the up-to-date draft of our own scheme of work for the IB. So the first thing to point out is that there are 2 possible streams for the IB. There is standard level, which is a little bit more basic, and higher level, which is at around A-level standard. The topic numbers on this page correspond to the topic numbers given in the IB specification, and that's just to help you if you're looking through the textbook, knowing where the likes of topic 2 and 12 occur. Okay, so they're not necessarily done chronologically. So you can see very similarly to what we had for A-level, there will be 2 teachers. So each class will have 2 chemistry teachers. The classes will be split equally between each teacher. The content delivered by one teacher is shown in bold, and the content shown by the other teacher is given here in normal font. The IB board is very specific about the amount of time required to deliver each part of the course. And this is just to help with planning, with teacher planning, and just for convenience. I've put those here. Okay, so this 13.5 means that the standard level part of the course requires 13.5 hours of teaching. And in topic 1, there is no additional content for the higher level students. Looking at topic 2, 6 hours are required to teach the standard level content, and in addition, a further 2 hours for those students studying the higher level stream. As a general observation, the topics are very, very similar between IB and A-level. Okay, so obviously chemistry is quite a ubiquitous subject. And I mean, all of these parts, atomic structure, chemical bonding, energetics, stoichiometric relationships, those topics are virtually identical to what we teach in the AQA A-level. Okay, so that is certainly a real similarity to be aware of between the 2 courses. It's worth being aware of the fact that we've tried to keep the first few topics as parallel as possible between A-level and IB, and that's just to facilitate students who might want to change between the 2 at the beginning of the course. So just looking down this general plan, one major difference between A-level and the IB diploma is this individual investigation. So each student has to do this thing called an individual investigation. I'm going to talk about it in more detail in a couple of minutes' time, but essentially it's a personal project. It lasts 10 hours, or it's supposed to last 10 hours, and it's marked externally. But as I say, I'll come on to that in a couple of minutes' time. And at the moment, our plan is to do the individual investigation in chemistry during the Trinity term. Okay, so it's obviously a fairly quiet term. The D block and the upper 6th are on study leave. It means that staff tend to have a little bit more time. It means that our technicians have a little bit more time. And it also gives students the opportunity to maybe use summer, if they want to write up or improve or really polish their individual investigation. So you can see that I've got a couple of deadlines here relating to the IA, the individual investigation. The school has set aside a couple of afternoons. So at this stage, these haven't been set in stone, but the idea is that chemistry would be assigned a couple of afternoons where we can have all students together just to really focus on these IAs. We have a deadline to submit the first draft before EXIAT in Trinity. This will then give your chemistry teacher a chance to look over and provide feedback. And then we've got a final deadline for the penultimate Thursday of the Trinity term. And that just means that your chemistry teacher then has summer just to give it one last look over. And if necessary, and if time allows, we can refine the individual investigations still further after the summer break. And you can see in Advent term, the course continues with syllabus level material. Again, all of these topics very, very similar to topics covered in the AQA A level. The only real difference is this option topic right at the very end. So the IB has various option topics and each department has to choose one topic. And having looked through all of them, so there are about 4 choices, medicinal chemistry, biochemistry, we've decided to study energy. Okay, we've looked in detail at those specifications and we've decided that energy suits the department best. And in particular, there are various parts which I'll show you that are quite similar to the IGCSE that we do here at Rugby School. Okay, so we're very well set up to deliver this energy topic. There are also several topics that the physics department teach here that I'll show you also come up in the energy topic. So it just made sense based on the strength of our IGCSE and the strength of the science department to do this energy topic. Okay, so looking inside this scheme of work, yes, so as I say, we've got standard level and higher level. So both standard level and higher level compose of 3 written papers, an individual investigation. Those 2 will be marked externally. There's a group 4 project, which will be marked internally and periodically externally moderated, and the same for the class practical work. It will be marked internally on a pass-fail basis and then periodically moderated internally, moderated externally, rather. And that practical work part is virtually identical to the AQA A level. So that's assessed in a very similar way. So external examiners will assess all 3 written papers and the IA. These parts account for all marks available. The statements in this scheme of work are the precise areas that can be examined and have been copied directly from the exam board specification. The statements in bold can be only examined in the higher level papers. So the higher level obviously being a little bit more detail and requiring much more class hours, okay, and therefore more content. Detailed descriptions of these external assessments are given on the next page, which I'll discuss in a couple of minutes. Your teachers will internally assess both the class practical work and the group 4 project. This will be marked on a pass-fail basis. The class practical work will be conducted during lesson time and the write-ups will be set as prep. The group 4 project is a 10-hour interdisciplinary activity. Students from different group 4 subjects will be assessed, will analyse a common topic or problem. Okay, so just as a reminder, group 4 is basically the science subjects, including sports science, but excluding maths. This exercise will be collaborative with an emphasis on process rather than results. And the group 4 project is also an opportunity for us to potentially collaborate with other IB schools in the UK as well as abroad. At the end of the course, you will be awarded a grade from 1 to 7. So that's another key difference with the A level. A grade 7 being the highest. And just to put this into worldwide context, around 7% of students receive a grade 7, 20% receive a grade 6, and 50% receive either a grade 4 or 5. And it's worth just pointing out here that that applies to both standard level and higher level. So both of those streams will be graded from 1 to 7. Just as we had for the A level, the page numbers that are referred to in this scheme of work correspond to the textbook. and we've already added them. Okay, so the department has already had a meeting, and following feedback from other schools and from colleagues who have already taught the IB, this is a textbook that we will be using. Okay, this one here. Okay, and you will be given a copy of that textbook on the first day of the course at Rugby School. So just like the A-level, it's a very big textbook. It covers absolutely everything, sometimes in a little bit more detail than is examinable, which is why we've provided you with the scheme of work. But again, we've got various examples here. And as I say, it goes through absolutely everything you need with extra details here and there as necessary. Just like the A-level, we've also been through a set of revision guides, and as a department we've decided this is the best. So again, just like the A-level, it's much more condensed, much more focused on the exam. But again, it's good to use that in combination with the textbook. The department will also look at subscribing you to a website. Having looked at a few at the moment, the one that we quite like is this one called MSJ Chem, and this is the address here if you want to have a quick look. So the department will organise you a subscription to that website. It contains a series of videos which your teacher could use to help supplement things like preps, and we could also direct you to them if you were unsure about a particular topic. Okay, and as ever, that would be in addition to seeing your teacher one-to-one as needed. So we've tried to summarise the assessments on this table, and I think I can just about get it onto the screen. So there are 3 papers. Paper 1 only contains multiple choice. It covers the entire course, excluding that option topic at the end, and Rugby School will be doing the energy topic. A calculator is not allowed. Okay, so again, that's a difference from A-level and even IGCSE. So a calculator is not allowed in that paper, and you're also only allowed a periodic table. So not the accompanying data. Okay, the timings are shown here. So a relatively short 45-minute paper for standard level, a little bit longer for higher level, and you can see that's reflected in the marks. But despite that, they have the same overall weighting. For paper 2, this is written answers only. Again, it applies to the whole course, excluding the option, which at Rugby School is the energy topic. This time calculators are allowed, and this time students are provided with a complete data book. Now, unlike the AQA A-level, where the data book is 3 or 4 pages long, the IB data book contains absolutely everything. So it's about 50 pages long. It contains absolutely every piece of chemical data you could possibly imagine. And it's quite a big publication, which you will be provided with in a proper bound form on day 1 of the course. Again, the timings are here, higher level again being slightly longer, that being reflected in the marks. And again, the weightings are slightly different. Finally, paper 3 is split into 2 sections. There's a data analysis section, which I'll show you some examples of in a couple of minutes. And there are some questions that are experimentally based. Okay, so Experimentally based questions are common to both IB and A-level. And although data analysis has a slightly higher weighting in the IB, the skills would be in common to both IB and A-level. Section B, written answers on the option topic. Calculators are allowed, and again, students are provided with the whole data book. Again, once again, got the timings, the marks available, and the weightings. Finally, for completeness, is the individual investigation. This is an original idea that is planned, conducted, and written up by each student. The write-up should be from 6 to 12 pages long. It's worth noting that the IB board have set aside 10 hours for this individual investigation. So we found from speaking to other schools that students tend to spend a little bit longer on it. But 10 is the timing that the IB specify for the individual investigation. You can see it's worth 24 marks, and at 20% of both standard level and higher level, it is worth a fair chunk of the course, and it is something that's really worth getting right. So just as a comparison with the AQA A-level, it's important not to make any direct comparisons. The two courses have completely different ethos, and talented students should be able to do well in both courses. There are a couple of facts that are slightly different between the A-level and the IB, and both of these will make sense to you as you move through the course. So from IGCSE, you'll have come across the molar volume of a gas. It was 24 cubic decimeters. That's the same at A-level. IB uses a slightly different temperature. Okay, so they use 0 degrees C, and the molar volume is slightly less to reflect that. There's also a detail here about something called a van der Waals force, and that will make more sense to you when you start the course. You'll come across it in the first term. In terms of the exam questions for the IB, this is an example of a data analysis question from paper 3. So you can see that the students have been given an unfamiliar graph of data. So it's quite complicated. There's quite a lot of data points there, quite a lot going on. And the students are asked questions based on those data points. Okay, so when we're talking about data interpretation, that's all we mean. Okay, so again, here's a graph. It's unfamiliar, so students would have seen it for the first time in the exam, and they just have to look at the graph and answer a series of questions based on that data. In terms of the option topic, I mentioned before that we've deliberately chosen energy because it has bits and pieces in common with the IGCSE that we do, and it made sense that given our students had done it before, that it would play to our strengths if we selected that topic. And just as an example of that, here's a question on fractional distillation. So students who've done the international GCSE, the IGCSE, will be familiar with this picture, and they will already be able to answer that question. Finally, I mentioned that there were parts of the energy option that were in common with physics. Okay, so again, we're quite keen to play the strengths of the science department, and this is an example. Okay, so things like nuclear fission and nuclear fusion are on the IB diploma for the energy option. They wouldn't be seen at AQA A-level, but things like nuclear equations for fission and sort of outlining how these reactions release energy and calculations relating to it would be things that we'd look at in the IB energy option. Just finally, I want to make a couple of very general points. You'll see from these IB questions that I've been through, I mean, I've got 3 marks here, but the rest of the marks on the page were 1 mark. Okay, back to this question, you can see 1 mark, 1 mark. Back to this question, 1 mark, 2 marks, 2 marks. So just very generally, in terms of the IB exam papers, it tends to be much smaller questions, okay, worth much fewer marks, okay, and that is one sort of theme that I've seen in the IB compared to A-level. Okay, if you recall back to the A-level questions that we were looking at, look, there's 6 marks. There's another 6-mark question. Okay, it's much more common to see much longer answers with many more marks required at A-level. Just finally, I wanted to quickly talk about the theory of knowledge. So you will have heard about the theory of knowledge, so TOK or TOK. So it is expected that at IB, your chemistry teacher refers to the theory of knowledge. It's not something that's directly examined, but it is an expectation that your chemistry teacher would talk about these things as the course progresses. Okay, so why do we know what we know? Okay, it tends to be quite metacognitive. You know, what experiments were done here, you know, how were scientists able to draw these conclusions? Okay, the only thing that I'd say with that is that it is explicitly expected, although not examined, in IB chemistry. But for A-level, taught well and as it should be, and as it is taught here, your teacher will also discuss these topics. Okay, so in terms of TOK, there is little difference between what is taught at A-level and what is taught at IB. Okay, so for example, the chlorination of drinking water is something that we'll discuss in both A-level and IB. Okay, and in both courses we would discuss various ethical issues surrounding the chlorination of drinking water. Okay, another example would be transition metal isomerism. Okay, taught at A-level and IB. Okay, you may have wondered how scientists 100 years ago were able to know about the exact structure of chemicals that they couldn't see. Okay, how did they know the shape of these structures? The reason they were able to do that was because they were able to resolve them into a certain number of isomers. Okay, so again, that's something that we talk about at IB, but it's also something that we would talk about at A-level. So there's really no difference between A-level taught well and IB theory of knowledge. So hopefully that's given you an overview of the Rugby School Chemistry Department's provision for both IB and A-level. As ever, if you have any specific questions, you can either email me, so that's SRB as the head of chemistry, or you can speak to your chemistry teacher. I hope that's been useful.